Hey guys, Travis Gillespie here. We've been looking at identity properties, and we looked at the identity property for multiplication. Remember, that's the one when you multiply any number by the whole number 1, it has a product of that other number. Well, similarly to that identity property for multiplication, we get into a concept of something known as reciprocal. So let's go write that down real quick. Or the reciprocal of a number. So let's go ahead and get rid of that s. Well, the reciprocal is one number in a set of numbers that when you multiply these numbers together, they have a product of 1. Well, let's take a look at the number 2 and ask ourselves, how can we get 2 to equal 1? If I were to subtract by 1, 2 minus 1 gives me a difference of 1. Or, if I were to take 2 and divide by 2, I would get a result or quotient of 1. But I'm not looking for a quotient. I'm not looking for a difference. I'm looking for a product of 1. I've got to use multiplication. Well, in a second I'm going to rewrite 2 back up on the screen. I just want to cross these two methods out. Subtraction and division aren't going to help out. We're looking for multiplication. We want to get a product of 1. So let's take 2 and ask ourselves, what can we multiply 2 by to get a product of 1? Well, earlier we found that 2 divided by itself equals 1. And division is the opposite of multiplication. Let's go ahead and use that opposite operation. So division and multiplication are opposite of one another. Since I took the opposite operation here, or used the inverse operation, let's take the inverse of this value 2. And the inverse of 2 is a fraction of 1/2. Well, half of 2 is equal to 1. So the reciprocal of 2 is 1/2. Let's go ahead and write that word down. This is the reciprocal right here. And you may also hear another term called the inverse. So 1/2 is the mathematical inverse of 2 in this case. So I'm just going to write AKA, also known as the inverse. Let's take a look at another problem. I'm going to put 10 on the screen and ask myself, what can I multiply 10 by to get a product of 1? Well, the reciprocal, or the inverse, of 10 is a fraction 1/10, or 1/10. 10 times 1/10 is equal to 1. Well, take a look at both of these problems. The value in the denominator is equivalent to the value that you're multiplying by. But how did this get us a product of 1? And how do I know that the reciprocal should be 1/2 in this case, or 1/10 in this case? Well, it goes back to looking at that division problem we crossed out earlier. Let's take a look at both of these problems a little bit further. I just want to change colors real quick. So let's draw an arrow over here. And I'm going to look at that original value 2, but this time I want to look at it as a fraction. Well, any whole number written as a fraction is that number over the number 1. So 1 will always be in the denominator. Well, how can I get the reciprocal or inverse of this fraction? Simple, just flip it. So 1 will end up in the numerator and 2 will end up in the denominator. That's the same as 1/2 over here. Well, when you multiply fractions, you multiply straight through on the numerator and straight through on the denominator. So 2 times 1 gives you a value of, I'm just going to put an arrow here, 2 times 1 gives you a value of 2, and 1 times 2 also gives you a value of 2, and I've still got my fraction bar in between. Well, this fraction isn't complete. It hasn't been simplified, so I just want to put an equal sign here. I can take 2 and divide by 2 to get a value of 1. Another way of thinking about this is any number written as a fraction over itself will always be equivalent to the value 1. Therefore, multiplying any number by its reciprocal gives you a product of 1. Let's take a look at that value 10 again. I'm just going to put our arrow down first. Now I have 10. I'm going to write it as a fraction, so 10 over 1. And to get its reciprocal, I'm just going to flip this fraction. So the inverse, or the reciprocal, is 1/10. And now we can multiply straight through on top and on bottom. So 10 times 1 gives us a value of 10. Also, 1 times 10 gives us a value of 10. So we have 10 over 10, which when simplified gives us a value of 1 over 1, or simply 1. If I were to take the number 1, let's take a look at this real quick, and divide it by any number. In this case, I just want to divide it by 10 because we used it in our last problem. This results in a quotient of 1/10. Another way of saying this is that this value here is the reciprocal of the number in the denominator. So the reciprocal for 10 is 1/10. So this is why in reality division is the direct inverse of multiplication, the opposite operation. The quotient, in this case 1/10, can be found by multiplying that same dividend, 1, times the reciprocal or mathematical inverse of that divisor. Well, the reciprocal of 10 is 1/10. And we've already learned through the identity property for multiplication, multiplying any number times 1 won't change that number. So your product is 1/10. Again, division is the direct inverse operation of multiplication. Let's take a look at one last problem. So let's take the number 8 and divide it by the number 4. Well, 8 divided by 4 is equal to 2, but I could use the inverse operation to get the same value. So in this case, we'll take 8 and multiply it by, I want to take the inverse or reciprocal of this divisor. So the reciprocal of 4 is 1/4. All I have to do from here is take 8 and rewrite it as a fraction. So 8 over 1 times 1 over 4. 8 times 1 is equal to 8, and 1 times 4 is equal to 4. From here I can simplify this fraction. Is there a number that goes into 4 and into 8? Sure. I can divide both numerator and denominator by the value 4. When you do that, I'm just going to show you that I'm dividing by 4 here on top and on bottom. So 8 divided by 4 gives me a value of 2. 4 divided by 4 gives me a value of 1. So from here, I can get rid of the value 1 in the denominator because 2 over 1 is equivalent to 2. So from here, what you can really see is that division is the inverse operation of multiplication. Cool stuff, guys. I'll see you in the next videos.